So today we're going to work on division. This is what students will be working on all this next week in 4th grade. And in 4th grade, just like multiplication, it's all about the strategies, not the traditional algorithm. That's for 5th grade. So we're focusing on making sure students understand what division is by showing us different strategies, more than one strategy. So I'm going to show you the two main strategies we use in 4th grade. We start with the one that they are better at and most familiar with, and it's drawing groups. And we only have one divisor, and we can have up to a 4-digit dividend. So this is going to be one of the hardest problems that they'll have to work on. And they can have remainders for their answer. It can be in a word problem. So you might see this in different ways, or it could be no remainders. So the students have to know that. So the first thing we do is we draw 4 groups, and I always tell my students to draw squares, not circles, because it keeps your numbers lined up better on your lined paper than when you add them up at the end. So squares, hint, great strategy. Then I have 7,413. I don't want to start with a small number. I want to start with the biggest number. I tell my students if the dividend has a thousands place, then I'm probably going to want to start and see if I can fit 1,000 in each box. So if I do 1,000 in every box, that's 4,000. That's pretty close to 7,000. So I'm going to go ahead and write 1,000 in each box. And students need to know their multiplication and skip counting for this reason. So 1,000, 2,000, 3,000, 4,000. And I always write to the side where I'm at. So right now I'm at 4,000. Now I know I have 3,413 left to go. So I know I can't put 1,000 in each one. So I go to my next biggest number that I can skip count by quickly. And we go 1,000 and then try 500. So 4,500, 5,000, 5,500, 6,000. And then I record where I'm at so I don't lose track of my number. So that's 6,000. Now I'm at 1,413. So now I can skip count by other numbers. I could try 200. That's another one that kids can count by quickly. So 6,200, 6,400, 6,600, 6,800. Now I still have, let's see, I have 200 to get to with the 7,000 and then 400 more. So that's 600. I can't do 200, 400, 600, 800. That would be too much. So I'm going to go to 100. 6,900, 7,000, 7,100, 7,200. So now I'm at 7,200. If I do another 100, that would be too much. So I'm going to try my next increment that I can skip count by quickly, and that's 50. So 7,250, 7,300, 7,350, 7,400. Wow, I'm really close to my answer, to my dividend. So I need 13. What can I split 13 into 4? I know my multiplication, so I know that 4 times 3 is 12. So if I put 3 in every group, I ran out of room, will get me 7,412. And I have 1 left over that I cannot fit in each box. So that would be my remainder. Now I add up the total in the box for one box. 1,500, 600, 700, 850, 3. So 1,853, remainder 1. So that's one way to solve the problem. Another way to solve the problem that we can use is partial quotients. And this is as close to the algorithm that your kids will for sure see this year. They have other strategies that they can use for smaller numbers, like skip counting backwards or skip counting forwards and thinking about it as multiplication, using multiplication facts, repeated subtraction, making an array. However, like multiplication, some of those are not efficient when you have bigger dividends, like arrays, repeated subtraction. It would take me forever to go from 7,413 and to subtract 4 every time. So I want to make sure that I use a more efficient strategy. And I can show you those strategies with a smaller number in just a moment. So 7,413. Instead of doing the algorithm where you're like, how many 4s go into 7? The kids think of this as 7,000. What do I know times 4 will get me something close to 7,000? Kind of like over here with the groups, I know that 4 1,000s equal 4,000. So I'm going to do 1,000. Now 4 times 1,000, that's 4,000. So I'm going to subtract and see what I have left. I have 3,413 left. Then I can go, okay, I know 4 times, and they might not know 4 times 500 off the top of their head, but they could do, I know 4 times 200 is 800. So I subtract what I have left. Okay, so I have 2,613. Then I go, oh, I know. 4 500s is 2,000. So it doesn't have to be in an order. And they might even do some work like this. 4 times 500. Sorry, that's 500. 4 times 5 is 20. And then I add, 2,000. 4 times 5 is 20, and then 2 zeros. So then that's what I subtract. 3 minus 1, 6, 2 minus 2 is 0. So now I'm left with 613. And then I can do, okay, 100. 4 times 100 is 400. So now I only have 213 left. That is, let's see, move that up a little bit. Okay. Now I can do, 4 times 20 is 80. 11, 10, 9, 8. 133, I can do another 80. Okay, now I have 53, so I can do 10. Gotta move it up again. So that is 13. Now I can do my 3. 4 times 3 is 12. There's my 1 remainder. And then I add up all the numbers over here. 3, 2, 4, 5, 5, 6, 7, 8. 1. 1,853. Remainder 1. So I get the same answer using, and the great thing about both these strategies is students use what they know about numbers. So they don't have to start with 1,000. There's no exact way to do it. There's lots of different ways they can break down the number, which that makes them feel better about what they're doing rather than saying, okay, how many 4s are in 7? And then subtracting how many 4s are in. That makes it a little bit more difficult and puts them in a narrow way. Whereas if they do it this way, if they start with a number that doesn't get them as far as they need to, then they can work around it. They can problem solve to get to their answer rather than if they mess up one way, then they've messed up the whole thing. Now I'm going to show you very quickly some of the other strategies that we use for some smaller numbers. So let's say we're doing 39 divided by 8. So one is skip counting, and I can skip count by 8. 8, 16, 24, 32, 40. Oh, 40 goes too far. So that's 1, 2, 3, 4 skip counts. And then 32 to 39 is remainder 7. Okay. I could also do an array and do 8 in an array. 4, 5, 6, 7, 8. And then I keep putting 8 in an array until I get to my dividend. Okay, so that is at 32, and then I have 7 more that will not fill up. 1, 2, 3, 4, 5, 6, 7. That will not fill up the rows. So I have 4 filled rows, and then 7 left over. Then something else they can do is repeated subtraction. 39 minus 8 minus 8. Oh, just lost my train. Minus 8. Minus 8. Keep running out of room. And then I can't minus 8 again, so that's how many times did I subtract? 1, 2, 3, 4. So that's 4 times I've subtracted, and then I have 7 left over because I can't subtract another 8. So those are some different strategies. Of course, they can always use multiplication. That's a great strategy, like 8 times something equals 39 or close to it. Well, then they would say, I know 8 times 4 is 32. 32 plus 7 equals 39. So then they would know this is their remainder, and that's their answer. Again, if you have any questions about any of these strategies, feel free to contact one of the 4th grade teachers. But this is what we've been working on. And again, these strategies down here only really are most efficient for smaller dividends. When you get to the bigger ones, repeated subtraction, making an array, and doing skip counting would take too long. So that's why we encourage them to draw groups. This is probably the easiest one every kid will get quickly. And then another way is to do partial quotients, breaking down the number into smaller chunks that they can divide. Thank you.